We have some more specific types of vectors and vector calculations. So first is the zero vector. The zero vector is if everything cancels out. Typically it's 0i plus 0j. Sometimes they use this funny zero to represent the same thing. Depends on what book you're using. The order of operation still applies, and you have to follow these rules for scalars and basic addition, subtraction of vectors, essentially. We also have the unit vector, which is the vector of magnitude 1. And the benefit of the unit vector is it maintains the same direction as the original vector, but has only a multiple of 1, so it's very nice for doing operations in physics and calculus. Of course, we only do I and j for 2 dimensions. They'll do I, j, and k for 3 dimensions there. So let's say I have this vector here. What is the equivalent unit vector? So it's a vector of the same direction, but only of size 1, essentially. So let's copy this right here. I'm going to copy that, because that's the formula, right? Because it's a vector divided by its magnitude, right? So if the vector is magnitude 20, divide by 20 becomes 1. If the vector is magnitude 37, you divide by 37, you get 1. Okay, so unit vector. Let's see if I can do this, sorry. Okay, so equals, we got to put the vector on top and the magnitude on the bottom. So the magnitude will be 5 squared plus negative 12 squared. Okay, let's steal the vector here so I don't have to retype it. Copy. Paste. Okay, so now we just get a little math now to calculate the unit vector. All right, so this is 25 and 144. So this is 169, which is of course 13, right? Okay, so the unit vector essentially equals, we're going to take this, copy, minus paste, right? So it's this minus this when I write it, right? So essentially it's 5/13 I minus style math. Yeah, okay, that's working. 12/13 the j. Can I just do it that way? Style. It did not work. Don't know why it didn't work, but it didn't work. Okay, so there is my unit vector. So the question is, did it work? So verify it is magnitude 1. Okay, so verification. Okay. All right, so format, color, blue, style, math. Okay, so verification. So I'm going to take unit vector, copy, and we're going to do the magnitude of it, right? So if I do that, that's the square root. Okay. So parentheses, we're going to take this fraction to the second, right? Plus this fraction to the second, right? So if I do that math, if you think about it, what are you going to get? You're going to get, squares go away, 25 here, and 169 here, 169 here, and 144 here. So that is going to be copy, paste. If you add those together, that is 169 over 169, which is 1. The square root of 1 is in fact 1. It is verified, so that in fact is the unit vector. Okay? All right. So the next thing is vectors in terms of magnitude and direction using trig. Okay. Well, if you think about a right triangle, no matter where you draw the triangle in the unit circle, right? So make your angle, right? There's my angle here, right? it's going to make a right triangle, right? So this is my opposite, and this is my adjacent, okay? Because this is your A and B coordinate, which is your X and Y, correct? Okay, which gives you your our value here. So if I multiply by the magnitude on both sides, right? Do that over here, and do that over here, right? That will cancel this, and it'll cancel this. That means A equals the magnitude times cosine, and B is the magnitude times sine, essentially, right? So the result is, okay, that A becomes this value here, magnitude times cosine, and B becomes the magnitude times sine. So I can replace A with this, and then replace B with this, and get my new equation, which works well for trigonometry. So one of the things you can do is vectors for velocity. You can also do force and a bunch of other things. So let's say I do a wind blowing 20 miles per hour in the direction of 30 degrees west, north of west, right? Well, if I draw that vector, right, a compass only goes north and south, correct? And so 30 degrees this way, right, that's northwest, isn't it? Because the west is over here. But that 30 degrees is not the trig angle, that 30 degrees. So a lot of people will take these bearings, which is what this is called, and they'll use that as their angle. That is not the angle. This is the trig angle, correct, which has to come from the standard position, right? That is 120 degrees, isn't it? Okay, because it's 90 plus 30 more for 120 degrees. So don't do that. So I'm gonna cheat here. I'm gonna copy this formula. Okay, and go to here. Oops. Picture, layout, square. Okay, so we'll calculate this out now. Alright, so I'm going to copy, paste. So the magnitude here is 20. So I'm going to replace this with 20. The angle is 120 degrees, correct? 120 degrees. Let's make sure you specify degrees and not radians, because that's what was given. Ooh. What am I doing? Okay, so I have a little math here. The cosine of 120 is negative 1/2, right? Using my unit circle. And the sine of 120 is root 3 over 2, correct? Okay. Because again, I'm doing this little coordinate right here, correct? This coordinate right here is negative 1/2 root 3 over 2, correct? That is my cosine sine in the unit circle for 120, right? Okay, so I do a little bit of extra algebra here. The vector would be what? Negative 10. And half of that will be 10 root 3, right? And I think I have it. There's my vector. Format, color, orange. Okay, here's the equation for my vector using trig, essentially. Let's say I do another one. It's that's the wrong direction. That was supposed to be south by 45 degree east. Sorry about that. Okay, let's say I do this one, right? So if I go south by east, right? This is south, right? And I'm going east 45 degrees. Correct? So this coordinate, that's not a good 45. Let's make a better 45 than this. Okay. This is 40. It's still not good 40 because it's supposed to be 45, 45. But okay, anyways, this coordinate here is root 2 over 2 and root 2 over 2, except this one's negative because it's the fourth quadrant, right? Okay, so that's my cosine and my sine value in the unit circle. All right, so I'm going to cheat here and steal this one from before. Okay, so now we're at 60 miles per hour. Okay, so what's my angle? Well, it's not 120 anymore because I have to go all the way around to the 45, right? The question is, what is that angle? So it's 90, 90, 90 plus another 45. That's 315, isn't it? Right, because you got 45 there. So that's 315. Okay, so this is 60. This is 60. We already talked about this. This is root 2 over 2 and root 2 over 2, except for the fact that it's a negative for the sine value in this quadrant, right? Because this is the positive negative quadrant down here. Okay, so that's going to be 30 root 2, correct? This will also be, but this will be negative now, right? So it'll be negative 30 root 2 is our vector essentially, right? So as far as our circle goes, right? Whoops. That's essentially what we're going to look like. That's our vector here. And the vector is longer because the unit circle will be here. It'll be a length of 1, correct? But this is our vector, which is, of course, much longer. It has a magnitude of 60. That's 60 long, correct? 60 miles per hour, right? And that's its direction, basically, which is done in I and J.